On the show today, we've got Cam Myers. He's the founder and CEO of CreateMe, a very interesting robotic solution for garment production, and we're excited to learn more. Cam, welcome to the show.
Yeah, nice to meet you, Mike and Jen.
Great. Well, Cam, I think we have not seen anything like what you guys are doing before, and we're very interested to learn about how you're applying robotics to garment production. I think it's a very interesting market opportunity. So why don't we start there before we get deep into the robotics part? Tell us about what inspired you to create and apply automation to garment production, and why that's so interesting.
Yeah, so I've been in technology for about 20 years, and in kind of my first startup before this, I was in e-commerce software space, and had exposure to some of the systemic issues that were going on in the apparel industry in terms of liquidation rates, stock out issues, and starting to see some of the problems that have really crystallized to the next level today in terms of this isn't Trump 1.0 and some of the tariff changes and what that impact was having in the apparel industry. And also at that time, I'd been sort of casting around thinking that this was a massive opportunity. It's an industry that's probably among the largest that doesn't have high levels of industrial automation, and seeing that this was a real opportunity that technology could be a bridge to rethink manufacturing, rethink onshore. And then at the same time, I had a series of colleagues and friends and acquaintances in Silicon Valley that were in automation manufacturing in kind of other industries in terms of consumer electronics, chipsets, things like this, and had seen the that curve of how greater levels of automation with robotics and other systems have happened over the last 25 years with the use of printed adhesive, laminates in a manufacturing process. So the example I think is really crystallizes that is if you think of a Nokia phone, 25 years ago, rivets, fasteners, soldering, putting that together. Fast forward to an iPhone, it's extremely automated, and it's printed laminate layers that are housing and putting that together. So our head of automation engineering comes from Microsoft and Apple, and very familiar with that process. And that was kind of the key vector to start wrapping some of our solutioning around with robotics, with automation process, but using the vector of adhesives for assembly rather than sewing. And so that was a really divergent starting point about how we started the solution.
Yeah, we've seen several attempts to automate clothing manufacturing over the years, and I agree with you. I think people aren't really aware how labor intensive it still is, and that we're still using methods that are probably over 200 years old in terms of putting together our apparel. But what were some of the challenges that you had to overcome in your approach to using robots to manufacture apparel?
Yeah, I mean, I think so. There's a small sort of handful of companies that have kind of thought about automation with robotics, and at a simplistic sense is can we attach a sewing head to a robot arm to manipulate and handle fabric? And that kind of design architecture choice has inherent constraints in it versus an adhesive approach. And really, it's there are several, but just from a pure technology point of view rather than an operational point of view, having to have two-sided access with sewing, because you have two layers of fabric, you're physically punching a needle below, and if anyone's looked up close at a sewing head, there's some negative space. So that makes it difficult, because you want to with adhesive you can have single-sided access. You lay down the adhesive, you bond. You don't need that other layer. So that also unlocks ways that you think about automation and robotics, because of the handling tools that you can use in terms of conveyor systems, vacuum systems, different end of arm tools, even 3D drapes about how you form. That's very hard going into a conveyor system if you're punching through a layer of fabric. The other reason why adhesive is a better vector is because when you align with robotic systems, you don't have to move it. Whereas with sewing, you align and you have to have continual movement. So those are kind of some of the benefits just at a very fundamental level. But to the kind of heart of what your question was also is, what are some of the challenges with adhesives? Well, you have sort of commercial challenges, which is this is a completely new way of manufacturing. So there's a design adoption curve, and there's explanation that goes on in terms of that it's not just a parity from a strength, washability, durability perspective, but it actually is superior, but it's not actually used. And so we're really the pioneers of using that. And so that's why when we thought about the categories that we started with, we actually started with women's intimates, women's underwear, because there's performance benefits of using adhesive because it's soft to the skin, it's soft to the touch. So that's actually the industry segment that is using adhesive already. It's manually applied, but that's the segment that's using it already. And then we've brought it into other categories like t-shirt. So that's kind of from a commercial standpoint, but from a technical standpoint, this is completely blue ocean territory. So when we first started thinking about how you form seams, this kind of stuff, just to back up for a second, adhesive is used in apparel. So I just want to make that clear. It's used as what they call a seam tape. So that is, you would see it in a Nike dry fit top and an Adidas sports performance apparel, or you see it as a laminate. But in terms of this microdot, gantry driven, printed adhesive form, that's like 1 or 2%, and that's where we're pioneering. And so, to your point about technical challenges, when we started out, before we even started thinking about how you do automated handling assembly, it was literally about the application knowledge of how you build seams that were performant and strong. They weren't. They weren't as strong. So there was a lot of tribal knowledge and sort of DOE experiments going in to literally like the diameter of the adhesive dots, the geometry of how one dot is related to another to mimic different stitch types, because there are different properties of stitches in terms of a neckband being very stretchy to get over your head versus a bottom hem on a t-shirt being taut. So a lot of application work. We've done literally thousands of experiments to get performant on durability, strength, this kind of thing.
Yeah, it's interesting. My mom taught foods and sewing in high school for my entire life. She was a high school teacher, so I'm very familiar with the sewing technology. I mean, she used to use a product called Stitch Witchery. It was like a laminate. You actually ironed it in, and the iron released the adhesive to form and bond between the two pieces of fabric, useful for thickening certain parts of a garment, I guess, or what have you. But what you just said struck me, and I didn't think about this when we were preparing for the interview, which is you're actually laying down, it's a dispensing problem partially, which we know robotics have been used for decades now, but it's more than just laying down. Maybe sometimes it's a continuous stream of some adhesive, but you're saying you actually have a dot pattern, different dot patterns that mimic the connection points that the thread have. That's what you just said, right?
Yeah, correct. And so, sometimes you'll see on a garment, they call it a bar tack, which is where the stitches go back and forth to give extra strength where it sort of pull apart. So there's all these types of properties that you want to develop. And that's what's really, we can do continuous lines of glue, which might be something interesting for outerwear, which is the segment that uses that uses seam tape, but really it's this dot matrix form that is quite revolutionary, because you're actually mimicking all the stretch and recovery properties of a stitch, because it is not continuous, and actually it is more performant in terms of the biomechanic movement, the sort of natural stretchiness than even thread, because thread is still it goes through at one point, but it is still connected, so that doesn't even have as much flexibility of movement.
Yeah. So how does that then change the bottlenecks that automated clothing manufacturing might have now? And you talked briefly about being able to lie flat and apply things. I'm trying to envision what this production line looks like now with this adhesive and the robots and what have you. again, trying to get back to the autonomy of what you're bringing together here, large scale production.
Yeah. So when we think about how we've developed our systems from a technology architecture point of view, what's kind of a unique conundrum or problem with apparel is how high mix, how high flex. So automation is all about constraints to do something repeatedly, but even in apparel, which is a huge billion, it's an industry that works in billions of units of global production per year, but the mix of products is extremely large. It's very different from iPhones where you're manufacturing 5 at a time, or Teslas. There's a handful of models. So your point is absolutely correct. How do you deal with sort of finishing steps that may be more peculiar to one particular type of product? And so the way that we think about that philosophically at a technical architecture is design to build as much of the garment in two-dimensional space as possible. And so that also means that we're going to much more akin or very close to a single piece flow model, much more of a lean manufacturing model. And if you ever see an apparel factory, it is the opposite of that. It's huge stacks of fabric. They are kind of the sort of the beacon for the Adam Smith division of labor model. You have one sewing operator just doing an action on a neckband, another one doing at the shoulder, that kind of thing. And so we wanted to flip that on the head. So we build as much of the garment in a 2D space as possible. That is the pacing element. So we're cutting and dispensing on a continuous conveyor line, and that conveyor line can support single and two ply. So a garment that is a single ply garment like underwear, or a garment like a t-shirt, which has got an A and a B, a front and a top. We have a system designed, and there's certainly some video on our website that your audience can look at that works with the two ply dimension. And then at the end of the line, we have these swappable cells that do the 3D forming steps, because human body is three-dimensional. And so the way that we deal with those bottlenecks, to your question, is that's where we line balance. So we use the pacing speed of the cutting and dispense conveyor system, and then we line balance. So clearly the speed of some of those finishing steps, for example, a neckband attach, or if it's something a little bit more unique, that a soft collar that you would have on a polo, those would be designed in work cells that are on the end of the line, and you'd line balance those.
So Cam, speaking about the technologies that you're using on the line, are you using commercial off-the-shelf hardware and software, or are you using custom design? I looked at the videos on the site, and it's really impressive that you have this, complete production setup. But how did you integrate all those things?
Yeah, so we use off the shelf, 6-axis robotic arms. We've used Fanuc systems as well as universal robot systems. Cutting systems are one of the few elements in the apparel industry that is automated. We use it in a different way than much of the industry because we're not doing large stacks of fabric that have been cut through. It's single ply. So elements of our system use in the 2D space might be sort of 50-60% off the shelf, custom integrated, and then obviously from an architecture and pattern perspective, wholly proprietary. But then when you get into the 3D space, this is a completely new paradigm for how you can build apparel. That's completely custom. So all those end of arm tools, those are completely custom, pretty sophisticated tools. The typical philosophy in the apparel industry for any point piece tooling of automation, is typically a jig or a tool for a size grading. So you end up having basically 6. One of the videos you can see the end of arm tools that we use pinch grippers and vacuum systems. It's all digitally. We call it digital adhesive. It's a digitally driven single piece flow system. So those tools are meant to cover all that variety from double extra small to double extra large, and any custom size in between. So the pinch grippers are moving in XY space. And then when you get to the other tooling that works in 3D, that is 100% custom and lots of axes of motion because you're dealing with three-dimensional space. So it's moving X, Y, theta, Z as well.
Well, and that's an interesting point because when you look at most clothing patterns, are flat, right? And so when you're moving to 3D or you enable more complex assembly, how much change do you have to do on the CAD side and the design side for the garments?
Yeah, there's fundamentally the kind of the mental model for the one of our customer sets is the product development people in apparel. We obviously have multiple people that we have to interface with, but that's obviously one of the key customers. And so the kind of the premise for them is aesthetically what we build is intended to look identical, both from a silhouette perspective, but also from a finishing perspective. The actual seams look identical. Now behind that, there are indeed changes. So there's certain things, for example, a shoulder seam typically will be a little bit forward of perfect symmetry. That is pushed back a little bit. We make also other changes on the interior side, so we can actually work with much tighter tolerances. So whenever you turn a t-shirt or another garment inside, there is a tolerance, and typically that's about 1/4 of an inch, and that's because it's humans that are making things, and there is always going to be that variability. And I think a good example is if you have a pair of jeans you like and you go back and get that second pair, it's not unsurprising for many people that may not be exactly the same, and that is just because there is that human element to that. So there is that standardization, which is obviously good from a cost and environment perspective of waste, but you're also actually getting a more standardized product. So there's smaller tolerances. So micro teaks in short on CAD, but aesthetically, it's designed to be the same.
And you mentioned that manual variance, obviously, versus the consistency of automation. But for more complex garments, are there still manual steps involved, or are you trying to completely automate it?
Yeah, I think it sort of depends on the product. So take, for example, underwear, which is one of the most simple products that can be produced. On some dimensions, that is complex to automate because it's a very flighty material, and it doesn't hide any imperfections. And it has very pointy angles that you have to kind of align. But more complex products, there is still human operator involvement. It's not underwear could almost be akin to like a Jetsons. You press a button and out pops the product. There are still humans involved, and that's a decided design choice because there's still quite a lot of extensibility in the product in terms of, say, for example, things like what neckband choice that you'd have if it's a thick neckband on a t-shirt or a thin one, or if it's a crew neck or a V-neck, or if it has a soft collar that you would have for a polo shirt or a pocket. But I think what is quite interesting, maybe for your audience, is that a paradigm of using adhesive is way more efficient, and I think it's probably similar to other industries going to adhesive versus soldering in terms of the labor pool. So outside of the apparel industry, I think some people have the idea that sewing is a minimum wage, but it's actually probably more in the $28 to $35 range, whereas the labor pool is a much broader pool. So it's the same pool that you would have for warehouse labor, because you're using a laser guided system to align something and then stamp and bond it. And so that's very attractive for our customers on the manufacturing side, because their challenge for thinking about opening up facilities in America is not so much, it is certainly a consideration, labor cost, but it's actually labor availability. They can't go into El Paso, Texas and say, hey, can we find 800 sewing operators? It just doesn't exist. So from a technical approach to how that relates to the business, using adhesive is a method that opens that up. And so, yes, people are still involved in more complex products, but the process is more repeatable because you're using vision guided tools to line things up, to stamp them. There's no movement with adhesive, whereas sewing, you're physically easing. You have to train that dexterity to guide things with your fingers.
And I guess we were talking about sort of the high volume type of product. Great place to start, of course, to prove this out, get the ROI with undergarments, that type of thing. But what about as you think about more complex garments and the adhesive opportunity, and even complex joints, darts, and what have you that have to change the design? I'm even thinking costuming here, opportunities as well, where it's a one-off type of thing for specific production that might be an ideal way to get something produced quickly that has a need. And then on that same thing, to finish up this sort of technology question, to handling things like zipper installations, classic difficult maneuver to get the zipper in straight and functional. Does it solve, or have you experimented with those sort of ideas?
Yeah, it's a good question. And our critical path has been on verticalized solutions for very high volume products. And what I would say, as you start to develop those, you actually build kind of building blocks that then allow you to do other things. So, for example, in women's underwear, you have a liner. The pattern architecture, the software fabric alignment, these techniques, at a fundamental level, what are you doing? You're laying a larger piece of fabric with a smaller piece of fabric over the top of that. So that metaphor of a building block then rolls in, for example, a breast pocket on a t-shirt. And so as we develop more of those tools, if we stepped outside of a strategy of kind of verticalized solutions, the types of things that we would look at could be more horizontal use cases. To the example that you're using of a zipper attachment that might be more general purpose, but for certain finishing steps. And so that is an interesting space, and an example of another more discrete use case. There's something that they call in apparel, which is what they call a fabric conversion, which is meaning taking two fabrics, laminating them together to create something different. So obviously, outerwear is a perfect example. You have an inner layer that has properties for breathability. You have an outer layer that has properties for windbreaking or waterproofness, and then you have down in between. That is complex for assembly. It's also complex for disassembly. There's certain things about our process that could support that, and we've had some exploration. So there are a lot of horizontal areas, to your point, that we could go, but we're starting with the big vertical ones. And I think that's fundamentally a strategy that we've made as a business, because all the solution that sewing has done is where there has been innovation. It's always been very much point solution based, and we felt that adhesive is just a different paradigm. So we're trying to build more platform oriented tools. But there is absolutely, and I think those opportunities would drive greater adoption as well.
So again, now talking about working with your garment partners, are you offering custom production lines? You just talked about trying to create custom modules for specific features and steps. But do you have a standard end-to-end that you can produce boxer shorts for a company, and then you're trying to sell that to multiple companies, and then they just run their fabrics through and they get a standard boxer pattern out of it, type of thing?
Yeah. So basically, I talked about there being kind of a 2D platform, a 3D cell. So that 2D platform is a standardized element that really works across all casual apparel, whether you're thinking about underwear, t-shirts, leggings, swimwear, that kind of thing. So that's almost agnostic. So if a different customer came for different products, that would be a agnostic system that would build probably about 65% of the garment. And then you have that 3D element. So yes, you have a quote unquote, as you said, an end-to-end, a factory in a box, solution. And as it stands today, we're just going into commercialization for our underwear solution, and that's, we're piloting that in our facility with with some OEMs, and then that will be deployed to their facilities, and then we're about 65-70% developed on the t-shirt 3D model, which is the next one, and then again that would be the same thing. You would be able to deploy that t-shirts model into a business.
So just to make sure I got it right, I heard you say that you've got sort of the flat handling, the 2D part of it could feed a variety of different products, right? Yeah. To the custom
point
cells,
of 60 to 65% finished of a garment, and then you have the 3D cell that does the 3-dimensional elements, and so that we built that for underwear, and it's about 65% built that 3D cell for t-shirts, and that'll be complete towards the end of the year.
So the same line could run men's underwear, women's underwear, t-shirts, and then the end would break out to the finishing cells for the specific garment type to finish it, kind of thing. That's your architecture for your system. I think
correct. It does provide modularity, but also there is efficiency in having that kind of on a continual basis.
Yeah.
Connected through.
I got it. All right.
So Cam, when you talk about, obviously you're looking to work with partners, and how does this approach shorten their cycle times, or how does it, change their whole look at production? And I know on your site you talk about getting closer to the consumer, right? And we'll go into that more in a moment. But how does this enable your partners and customers become more nimble?
Yeah, it's a radically different approach to manufacturing, at least for the apparel industry. And sometimes, in some ways, the apparel industry is got different points of reference. So it is the single folk system, and so it allows you to be very nimble from a point of view of peak efficiency. For us is one roll of fabric. But depending on the garment, that it could be a couple hundred pieces. Overseas MOQ minimums are into the thousands, and that's not floor efficiency. That's peak efficiency. So to kind of blow that out, if you're working within the same fabric, you can be moving between different series of permutations of silhouettes and size gradings within the same product. So very low MOQs, very low minimum color quantities. It's sort of a 7 to 21 day turnaround delivery, and it's very, because it's digitally driven, like you don't have the jigs to move between different size gradings of different things. It's very flexible and efficient. I think one of the best expressions of like a very kind of tactical thing, but it's a real thing for a manufacturer, is if you're moving between different colorways and you've got 100, 200 sewing machines, you need to re-spool all of those threads for whatever that new color is, and that's more safety stock and more management. This is translucent, so it doesn't matter. It could just move from one fabric to another. So it's very flexible at that point, and that's absolutely kind of at the heart of this kind of pull model on demand. Notwithstanding that, obviously, it's also about the economics to be cost competitive in market rather than air freighting or being on a boat, for 45 days.
And does that then also help apparel makers move with new fashion, new design more quickly? Because if you have a CAD design, you can just upload that and things are almost ready to go, because you don't have to worry about respooling and all those other material things. And how does that affect, because you're talking about reducing waste, how does that affect inventory as well?
Yeah, it's a good question. I can sort of combine the two parts. So yes, for those reasons of kind of quick reaction to demand, it provides efficiency. The other thing I would say is for an apparel manufacturer, one of the terminologies they talk about as your core product, maybe your evergreen product. So let's take a hypothetical example. A brand has standard core T-shirts that they offer. It's the things that are at the margins, what they sometimes call kind of core plus, which might be, so say, for example, really small sizes, or like big and tall, like it has along, if you're 6'5", those things. Those kind of elements, the tails are very hard to forecast. And so the notion, like the very specific tactical use cases, is they can burn down that inventory that's harder to forecast versus the mediums and larges, and then have that quick response. So to your point about inventory, that's kind of how that stuff is harder to forecast, and how can that could be quick reaction, but also it could be a silhouette or a design change. And the last thing I'd say, a lot of the innovation in apparel in the last 25 years from a technology point of view has been in the finishing space. So it's different ways to distress. You can see T-shirts that look like they're vintage, but they're not. There's technology that's developed for washing cycles to do that. There's digital print tools that support rapid on-demand. So rapid on-demand finishing or embellishment is very much a dovetail to on-demand assembly. So to your point about different fashion styles, whether it's licensing or something that's kind of topical in the news, a meme or a moment in sports, being able to quick react with that. The idea is for those to very much work together.
So to play devil's advocate here, we're talking about being nimble and agile and responsive, but on the flip side, with the latest round of tariffs, does the end of the dimminimous exception affect fast fashion? Is that going to change consumer behavior or expectations? And what does that mean for CreateMe? Does that open up new markets or opportunities? Like, how do you see that?
Yeah, so I think the traditional leaders of fast fashion, of the likes of Inditex and H&M, these types of companies, have been very successful traditionally over time. But then, obviously, to your point, there's been these new players come in, like Temu, Shein, and with the unwinding of those de minimis rules, I think you will see it allowing for other companies that have kind of played by the rules on some of those tax things to equalize. So I think that's not necessarily something that's peculiar to us, but I think that's just a more writ large shift that you will see. And I think I've seen data that suggests that it's already occurring, that Shein and Temu's growth has been actually flat in the last month, with these changes on the books. In terms of what impacts on us, I think it's probably less the de minimis piece, but just the tariff regime change in general has been very, we've been thinking about this for a long time. And I think actually the people that are at the coalface of this in supply chain innovation supply, they've been aware of this stuff for a while, because you had those shocks to the system, with COVID. You had obviously the first regime tariff changes and the first Trump administration, and so there already had been a move towards what they call matrixing your supply chain. So don't be all in China, maybe be some in Vietnam. And I think what's been a realization is you need to spread your resources. So have some have some offshore, have some nearshore, have some onshore. And for that nearshore and onshore, there has to be different changes to the business model equation to make that work. Technology has to be a part of that. And so we've seen a lot of inbound interest, since those changes in April.
And does that pose an opportunity for reshoring production of garments into the U.S.? So I live in New England, and there's a lot of old mill towns around here, and people forget that during the first industrial revolution, one of the reasons why we became an industrial power is because of apparel and textile manufacturing. Is that something that by using automation and getting close to the consumer? Is that something that you see as an opportunity for manufacturing?
Yeah, I think absolutely. And one of the paradigms that I would use, and certainly people in industry are thinking about this, is the old model was very much building a supply chain for the lowest possible cost. What you're really seeing today is building a supply chain to de-risk. And so that's de-risk from shocks. But I think there's also a growing awareness that, one of the kind of stats rule of thumbs is, many brands are operating in a 65-70% sell through, meaning 30 to 35% is discounted, liquidated, destroyed, which is, quite astounding that the business makes money with that in place. Now, that's in part a function of such a stretched supply chain, that the demand and supply signals are so spaced out. So being more proximate to the consumer, being close to the consumer, actually is very helpful in getting better economics, because that movement of your unit price up and down by 5% has way less impact on the bottom line than moving your sell through from 65 to 70 to 75, which you're selling at full price. So yes, absolutely. The tariffs are having the impact. I would say it's also making people rethink a little bit the supply chain strategy of de-risking, your whole inventory, these kinds of things. And yes, you need technology to make the equation work.
It's been fascinating, this conversation, because this is such a mature manufacturing space that we don't often talk about innovation in automation here, and you guys are sort of turning the world of garment manufacturing upside down with this concept, which is really fun and interesting to explore. And so, as we've come to understand, your basic cell design, production design for again some basic garments, but looking forward, where do you think this goes? What sort of trajectory do you want to see CreateMe take if you can force that function down the road in the next 5 to 10 years as this evolves?
Yeah, so I think our value proposition at its most core from a technology point of view is being experts in automated assembly with robotics, with other systems for deformable objects, and there's a really strong software stack to that. Principally, computer vision, machine learning driven. We're starting to look at some AI tools around that, and so I think that will drive a different paradigm for assembly and ultimately an installed base of systems within the apparel industry. And I think our fundamental vision is really all core apparel can be built more efficiently and actually have consumer performance benefits with adhesive. So we would like to be a part of driving that adoption curve. But in terms of your question, in terms of a little bit more of a macro view, our skill set from a software point of view, in terms of sub-millimeter precision, alignment, and handling, is very conducive also to other applications. Some of the end-of-arm tooling for other industries that use technical textiles in other contexts. So there's adjacent. I think of apparel as the biggest rock on the biggest hill in the space of textiles, but there's all these other adjacencies. If you think of composite layup, in aerospace or defense, that's still a very much a manual process of how that layup works, or how leather is used in upholstery and seating and automotive and aerospace. So there's our adjacency, particularly on the software side of the computer vision alignment, things like that could ultimately over time translate into other industries as well.
When I was thinking other sewn items in our life, whether that's bed sheets or draperies or other types of things that have
there's a whole slew of things, and also I would add, for the audience, in terms of our vision, is there's a very strong pipeline that we're building, on the adhesive side. So we've developed. One of the things we said when we started the company and started to think about automation with adhesive as a platform was, well, upstream, because we're in the manufacturing process, is there things that we could think about differently from the point of view of recycling by using adhesive rather than thread? And if you think about how adhesive is used in automation manufacturing, and say, for example, electronics, e-textile, e-waste, they freeze it to, heating is not good because it, might create problems with lithium batteries, but that's a process. And so we've developed some adhesives over the last couple of years that can delaminate at the end of life, heat activated above kind of wash and care. So I think there's also some interesting things in terms of how this platform could have from the point of view of helping support recycling, because recycling in the apparel industry is most, what they call kind of post-industrial in terms of scraps off the floor, much less, post-consumer. And one of the issues is, just like other recycling streams, you need to separate your waste streams, like your aluminum from your organic matter. You same thing, cotton or natural fibers, from poly fibers or zippers, that type of thing.
So Ken, when you're talking about, the reversible adhesive and the life for garments, there is the recycling angle, and we know that apparel is one of those things that gets returned an awful lot, right? And that's one of the big challenges is that a lot of retailers would rather send the returns off to the landfill than recycle or reuse the cloth or the material. But it sounds like you're able to potentially disassemble or even reuse parts of the garments. Is that right?
Yes, that's the idea, and obviously, it's a complex ecosystem. So we're developing partnerships, and because we're very much upstream. But yes, if you have the forethought of how it's constructed to be conducive for disassembly, well, then you're essentially halfway there for that problem. There's no efficient way, for disassembly of, if you have a panel that's a poly versus a cotton, it is a manual process of separation.
And a real cost involved in that,
Yeah.
which is maybe not even worth doing, which is, again, why it's cheaper to throw it away than it is to disassemble and reuse. Well,
and that's why, post-industrial, the scrap floor, where they know that, hey, this is all unadulterated, the same stream, it's all cotton, that's why that's a much bigger part of what recycling is in apparel versus, on the consumer product side.
Well, Cam, this has been a fascinating conversation. I learned a ton today. So I want to thank you for sharing your vision, sharing what you guys are up to. Definitely look forward to following your success now going forward as you guys get better at what you're doing and develop more elements around it. So thank you for coming on the show and sharing it with us.
Yeah, thank you very much. And if your audience, if you have any questions, we're very, very happy to answer any. But yeah, it's been a pleasure talking with you guys.